Welcome to Python tutorials with Simplilearn. So let's begin. Before we move ahead, let's have a look at everything that you learned today. So first we look at what exactly these tuples are, what is a variable, and finally what lists in Python are. So let's begin. What are tuples? A tuple is a collection of immutable heterogeneous Python objects. So the extra term that comes in case of tuples are that they're immutable. So over here, we have a tuple that's x, and within x, we'll store various elements, 1, 89, a single letter A, which is a string, also a word, which is again a string in Python, hey, O, and B. So as you can see, this tuple here may not be necessarily completely filled with integers, completely filled with floats or strings. It can be a mixture of all of these data elements. So that is one advantage we have when it comes to tuples and lists as compared to arrays. Because with arrays, you can have only one data type elements within it. Now we look at indices. So every element in a tuple takes up a position. And this position is what we refer to as an index. In plural, that's indices. So tuples positioning or the indices for tuples and list strings also in case of Python and most other programming languages starts with 0. So your element 1 is at the 0th position, your element 89 is at the first position, and so on, where B is at the 5th position. So in a way you can say that the length of your tuple x is 6, but then the last index of your tuple x is 5 because it starts from 0 onwards. So now that we have a basic idea of what a tuple is, let's begin with creating tuples. Creating tuples. Now the first thing that we are going to do is we'll create an empty tuple. So say my empty tuple's name is EMP. All you have to do to create an empty tuple is give these curved brackets with no elements inside. So this is a lot like lists, but in case of lists, we had square brackets. In this case, we have curved brackets. So that's the only difference. Now if I print the type of EMP, you'll see it's of class tuple. I can also print out just EMP. And since EMP is an empty tuple, there's no element within it, but then of course the brackets are still printed because that's a list, because that is the basic characteristic of a tuple. So even if it's empty, these brackets would still be existing. So we saw how to create empty tuples, but how often do we actually use empty tuples? So let's put some elements into our tuple. So let's start with creating a tuple with just one element. So say my tuple's name is city and I'll have one element, Pune, if you're creating a tuple with one element. If you're not putting the brackets, it's completely valid as long as you have a comma after that particular element. So with this kind of a syntax, you can create a tuple. So I'll create a tuple, say city, and I'll just have one element within this, which is Pune. Now, if you're not putting this element within these curved brackets, that's very characteristic to tuples. It's completely okay while creating a tuple as long as you have a comma after your element. So although you have no element after this comma, that one single comma is important. So let me run this and just type of city. As you see, city has been stored as a tuple. Now, in the most standard way of creating tuples, you'll say city and within brackets, you'll pass your element. Also print out city after that. And the same syntax can be used. And then you can also combine these both, although that's completely unnecessary effort, but it's possible. It does not result in an error. So you have your brackets and the comma. Works just fine. Now I want to add more elements to city because clearly Pune is not the only city we know. So Pune, Bangalore, these are some of the cities in India if you're from another country and wondering. So after this demo, you not only know tuples, you also know a few cities in another country. So I have 4 elements in this tuple and this is how you create it. All the elements separated by commas and within brackets, print out city. Now I can do the same thing without the brackets too. Just the commas indicate that this is a tuple. Now those are the various ways you can create a tuple. Of course, all these ways do not come handy. Usually you use this method to create a tuple with n number of elements. And when it comes to one element, you usually go for this. Just put one element within the brackets. This is also used sometimes. Now another thing we saw while learning what a tuple is or looking at the definition of a tuple is the word immutable. So we said lists are mutable, which means that they can be changed, and tuples are immutable as in they cannot be changed. So here we'll see a small example as to what the difference between tuples and lists are when it comes to the execution of these both. So say I have a list 1, and that has elements 1, 2, 3, 4, and then I have a tuple, say tuple 1, which has the same elements 1, 2, 3, and 4. Now with list 1, I'll use this method that you probably have encountered before called append. So I say list dot append of 5. So what this function does is it adds 5 at the end of this list, which is list 1. Now we'll print out list 1. Run this code, and as you can see here, 5 has been concatenated to our list 1. Now let's try the very same thing in tuple. So tuple 1 dot append 5, and I'll run this and see you get an error here. So the tuple object has no attribute append. In fact, it has none of the functions which you usually use with lists, because these functions aim at changing the original list and not giving back a new list. In tuple's case, you cannot change the original list. Once your tuple is set, that is how it's going to be as long as it exists. So that is the main difference between lists and tuples. List is mutable, whereas tuple is immutable. And other than that, of course, you must have noticed the syntactic difference, which is lists are with square brackets and tuples may or may not use parentheses or the curved brackets. So every time you print out a tuple or you view a tuple, it's always got those brackets. But as you saw while creating a tuple, sometimes a comma is enough. So now let's access these elements in a tuple. If you want to print out the entire tuple, we already saw, just put it in a print statement, put the tuple list, put the tuple name in a print statement, and you'll have your tuple printed. Now, if you want to access some particular element of the tuple, say I want to take out Bangalore. So in that case, we use the indices as we saw earlier. Indices start from 0 and Bangalore is therefore at the first position. So I have to just say city and within square brackets 1. So this particular line or this syntax is exactly the same as you would use for a list or string. Just run that and here we go. We have Bangalore. Now we can also extract elements from the end of the string, just like we did in case of list. So if I do not know the length of the string, now suppose I want to access the very last element of my tuple, but I have no clue as to what the length of my tuple is. In that case, what index do I use? Well, I can just go with -1. Now every time you give this minus sign, it starts accessing elements from the end of the tuple. So -1 means the first element from the end of the tuple, which is Mumbai. And that's what we got as our output. Now, although lists are immutable, there are a number of operations you can still perform on them. For example, the very first thing we look at is concatenation. So I already have my tuple city. We'll just print it out once again here to see what it consists of. Now we'll create another tuple, say num, and this will have the elements 1, 2, 3, 4. Now sure, I can't modify tuples, but I can definitely concatenate these two. So how do you do that? Extremely simple. City plus num. The plus sign works perfectly fine for concatenation. So I will print this out. And we have an error here. That is because we have not compiled our num list first. So our num list is not existing right now. I ran my line 19. Now I can run the next line. We have one complete list which has all the elements of city followed by the elements of num. Now you can also nest tuples. That is, you can have one tuple within another tuple. So far we have a tuple city and num. Now I will create another tuple. Now we already have our tuple city and num. What I'll do is I'll create a new list, say nest. So this is going to be a list. So we have our brackets here. So what I'm going to do is I'm going to create a tuple within another tuple. So we have a new tuple, I'll call it nest. And since this is a tuple, the basic syntax, I'll have the brackets. Now what will be the elements within this? The elements would be my other two tuples, which are city and num. So I put in both my elements here and let's see what nest contains now. So nest is a tuple which itself contains of other tuples which are city and num. So that is how you nest tuples. Extremely simple, isn't it? Now here's something else. Say I want to create a tuple rep which has an element Python, but that element is repeated 5 times. So what you would generally go for is type out Python 5 times. But thank God for Python, there's a much simpler way of doing this. Type in Python once and multiply this 5 times. Let's print out rep now. And as you see here, Python exists within this tuple 5 times. 1, 2, 3, 4, 5. Now maybe this is not how you want to create your tuple. You want your tuple to just have that one element Python initially. But later on, while printing, you decide, you know what, I want Python to be printed 10 times within this tuple. Not a problem. Put your tuple name here and then go for it into 10. And as you see here, the tuple has now 10 elements within it. So guys, remember, when you're putting the statement here, it's not actually modifying the tuple, it's just printing it this way. So if I say rep once again and I run this tuple just has one element. So next we look at slicing in tuples. So we created our tuple num previously. I'll just print that out once again. So it has the elements 1, 2, 3, 4. Now suppose I want all the elements from 2 up till the end of this tuple to be printed. In that case, what I do is I go for slicing where I will mention my beginning and my end index. So my beginning index starting from 2 is of course 1. And my end index is basically the position 4 is at, or till the end of this tuple. Now when I want all the elements up till the end, I do not need to mention my end index. It's by default taken so. So if I just say num of 1 up till blank, run this, your tuple sliced, it gives out the elements at the first, second and third position. Considering 0th is our first position of course. Now you can also print this num tuple in reverse using these indices. So you say num, I leave my start and end index empty, give 2 colons, and then in the end I have -1. So when you put this -1 here, so it basically prints out the reverse of your tuple. Let's check that out. And as you see, your last element is now your first element, and your first element is now your last element. If you have any doubt regarding how slicing works, please check out our video on Python lists. Over there, we have a detailed description on how slicing is, and there will be no confusion since in case of slicing at least, tuples and lists are exactly similar. So let's look at this string that I have here, Simplilearn. Now I want every letter of the string Simplilearn to be an element of a tuple. How do I do this? Well, pass the string as a tuple. So write tuple of, and within this, you have your string, which is again within quotes, right? We'll run this command. And as you see here, every character is now a separate element in a tuple. So this procedure is called unpacking. Now I'll just print out my num tuple once again so we can see what's in it. Okay, so I want to put these elements which are inside a tuple into various variables. Now in this case, I know that my tuple has 4 elements. So I can have 4 variables A, B, C, D. And I'll put this equal to num. Run this and then I'll print out A, B, C and D. So every element of the tuple has gone into one of these variables. The first element went into A, second element into B and so on. Now what if we had no clue how many elements are there in num? In that case, I could say A, I want my first element to go into my first variable A no matter what. And I want my last element to go into this variable C no matter what. Now all the elements in between, I'm not very concerned about where they go. So in that case, I can have another variable B, but this variable will be a list. So the star indicates that B is a list. And then this is equal to num. We print out A, B and C. So you see what happens here is my first element went into A. And my second element went into C because these were clearly indicated. But every other element in between went into my list B. So that is how unpacking works. So since tuples are immutable, it's impossible to delete the elements within it. But that does not mean you cannot delete the tuple entirely. So that is what the del keyword does. We'll implement this. So I'll create a tuple, tuple1, and put some elements into it, 1, 2, 3, 4. Now, I'll use the del keyword. Now, I'll just print out this tuple. So we know it exists and what all elements are within it. So great, our tuple is created. It has the elements 1, 2, 3, 4 within it. Now I'll use the del keyword to delete this tuple. So I say del space followed by your tuple name. Run this command. Now let's try printing tuple1 once again. Of course, since we did it all right, hopefully, this tuple should not exist and this should result in an error. And it is resulting in an error. It says tuple1 is not defined. So you can completely delete the tuple if not delete elements within the tuple. So as I mentioned previously, most of the methods that you have with lists does not work with tuples because these methods change the original list itself. But there are a few built-in functions which do work with tuples. They return values or new lists and they do not have any impact on the original tuple, so it works just fine. We'll explore some of these built-in functions. I'll continue using the tuple I created before, that's num. So I'll create a new tuple, num1, which has the elements 3, 5, say 4 2s, 6, 5, 8. And now we'll perform our built-in function operations on this num1 tuple. So the first one that we look at is counting the number of occurrences of a particular element. So that is the count function. So you give your tuple name dot count of and the element whose count you wanna know. So I want to know the number of 2s in my tuple num1. Run that, and as you see, there are 4 2s. Now you can also find the sum of all the elements within your tuple. So that is sum of num1. You just have your function sum, pass num1 to it. Now this sum function works for tuples, lists, everything. It's not a function particularly for tuples as such. So the sum of all the elements within a tuple is 35. And in a similar way, you also have the len function, which is in fact even used for strings. So len of num1 gives the number of elements within num1, which is 9. We have 9 elements. But remember, our last index is 8, not 9. Our element is 8 too, coincidentally. Now we have the max function for finding out the maximum number in your tuple. So say max of num1, which is 8. And we also have a function for checking the minimum of the numbers within our tuple, which is 2 in this particular case. So now list and tuple are very similar in the sense of what they hold. So what if I have a list, say LST, which holds the elements 1, 2, 3, 4, and I want to convert this list to a tuple. So we'll see how that is done. First, I stored my list 1, 2, 3, 4. So I'll just check the type of the variable LST, ensure that it's a list, which it is. Now we can convert this to a tuple. So to convert this to a tuple, enter your variable name and then pass your list name within these braces for the method tuple. Run this code and now let's print out TPL, and as you see, our list LST has been converted to a tuple. We can also check its type. So yeah, a conversion has worked out fine. Now this kind of a situation often arises when you put certain elements into a list. So you create a list that you desire and then you realize that you don't want this to be changed at all throughout the program. So then you can convert the list to a tuple. You cannot convert a tuple to a list though. So we previously saw how we can have nested tuples, that is tuples within tuples. Now we can also have tuples within lists. So we'll check that out now. Say I have a list LST and within this list I'll define my tuples. So 2 of the elements of my list LST will be separate tuples. I have a tuple 1, 2, 3 and I'll have another tuple as the second element of my list as 4, 5, 6. So I'll run this code, print out LST. So LST is created just fine. It's a list which holds 2 tuples. Now tuples are immutable, but lists are mutable. So we can add as many tuples as we want inside this list. So we can make modifications to the list. So I could say list.append, and to this I'll pass another list which has 3 elements. Say tuple inside list. Run this code. Now if I print out list, you'll see that the third tuple has also been added to the list. Now we can also remove tuples from the list. Just use the remove function. So lst.remove, and within this I'll pass the list that I want removed, which is my first list in this case. So run that code and print out the value of LST to check what's in it right now. So our first list has been removed. Now we just saw how you can nest tuples within lists. Now we'll check out how we can nest lists within tuples. So I'll create a tuple TPL, and within this tuple I'll have 2 elements, each of the elements being a list. So they have A, B, C in my first list and D, E, F in my second list. Run this and print out the value of tuple before we proceed. Yeah, so that's our tuple with 2 elements, each element a list. Now we cannot modify tuples. So initially when we had tuples within lists, we could add more tuples to that particular list. But now we have lists within tuples and we cannot add more elements to this already defined tuple. But what we can do is we can modify the list within the tuples. So I can add elements to the first element and the second element of my object tuple. So I'll try that out. If I say tuple 0.append. So when I say tuple 0, it's accessing the first element of the tuple, and the first element of a tuple is a list. So to this I can use the append function and I'll append an element z. Run this code and then check out the elements within tuple. And in the similar manner, we can also remove elements from the list within this tuple. So I can say TPL of 0 dot remove Z and then print out TPL. So you see Z has been removed here. Now just for the sake of it, let's see what happens when we try to add another list to this tuple. So I say TPL dot append and pass a list X, Y, Z and then print out TPL. So we get an error because this time our object was a tuple, not a list, and tuples cannot be changed. So with that, we saw the many concepts that is used with tuple along with what tuple is. We'll quickly now have a very short exercise where we'll recall some of the concepts that we previously saw in this video. So what is this exercise that we're planning on doing? We'll initially create a tuple which has the digits from 0 up till 9 called tuple 1, and then we'll create another tuple by adding an element to this tuple 1. So we are not adding an element to tuple 1 and modifying the original tuple, but we are creating another tuple using the elements in tuple 1 and adding another to it. Then we'll create a tuple by adding the reverse of tuple 1 to this tuple. So first we have tuple 1 which has all the elements, then tuple 2 which has all the elements of tuple 1 plus another number, and then we have tuple 3 where we have all the elements of tuple 2 plus the reverse of tuple 1. So let's move on back to the Jupyter notebook. I'll create my tuple which is called series 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's my first tuple. And I'll print this out. So tuples created. Next thing we do is we create our second tuple which is series 1. Now series 1 will have all the elements of series plus another element which is 10. So how can we add another element to a tuple if we are using... So how can we add another element to this tuple without manually typing it out? Now, as we saw previously, we can concatenate tuples. So we can say series 1 equal to series, and we'll add the second element as an element of another tuple. So instead of just saying 10, which is not possible because series is a tuple and 10 is an integer, we can say a tuple which just consists of 10. Run this code and print out series 1. So we have successfully been able to add another element to series and create another tuple series 1. Now we have to create a third tuple series 2 which will have all the elements of series 1 plus the reverse of series. So again we are going to use concatenation to bring both these tuples together. Say series 3 equal to series, and of course I can just say series and plus, but just for the sake of recalling once again how slicing works. So yeah, I'll put an 11 here, and now to that I'll add the reverse of series and not series 1. So I'll just make this correction in the previous one. It's supposed to be series 1 here and not series. And here I need to reverse it. So as we previously saw, I'll put -1 here and leave the beginning and end indexes empty. Run this and print out series 3. So we have all elements of series plus the 10 which makes up series 1 and then the reverse of series. So here's a very simple statement, x equal to 100. A variable's definition is basically an entity of a program that holds a value. So in this case, x would be our variable and 100 would be the value it holds. To better visualize this statement, let's consider a box. Now if this box holds a value, say 100, then the name we give to this box, which in our case is x, would be the variable name. And 100, that is the content within the box or within the variable, would be the value of the variable. Now this is the basics of what a variable is. As we'll go through the various topics today, you'll have a better understanding of why we use variables and how to use them. So let's move on to the next topic, which is the various data types of variables. Before we move on to this, let me explain to you what data types are. If you have dealt with other programming languages before, you probably already know what data type is. But just in case you haven't, data type is basically the type of value that you assign to the variable. So in our previous example where we said x equal to 100, in layman terms 100 is a number. So the data type would be number. But when we come to programming languages, there are two types of numbers. There are integers and there are floats. Integers are basically numbers without decimal point. Floats are numbers with decimal point. Other than this, a very common data type that we have in Python and other languages is string. So string is any word. In technical terms, we call them a collection of characters. Python also has a few of its own data types, as we will see. So let's move on. So I'll move on to my Jupyter notebook. So the first data type that we'll be looking at is integer. As you saw in our previous example, x equal to 100 is an apt example for this. Let me run this statement. As you can see, there's no error. That means this assignment is proper. Now we'll check the type of this variable. So type, and within brackets, you enter x. Run this, and as you can see, the type is int. So int is the short for integer. Any number without a decimal point comes to int in Python. Now this is not the only way you can assign values to variables. You can also assign values to variables while simultaneously performing arithmetic operations on them. So 654 into 6734, enter. Now let's check out the type of this variable, which would be int again. Now if you print the value of this variable, you'll see that the value x stores is the product of these two numbers. So now let's move on to the next data type, which is float. X equal to 3.14. As you can see, this is a number with a decimal point. If you run this, there won't be any error. So this is a proper assignment statement. You print x and the value is printed. Now you print the type of x, run, and it's float. We'll move on to our next data type, which is strings. So string is any word, it's a collection of characters. So x equal to, and within quotes, so I'll type Simplilearn and run. So no error, print x, and the value of x is printed, which is Simplilearn. So guys, whenever you're assigning strings to a variable, it's important that you do them within quotes. Now you can do them within single or double quotes. I'll show you how it's done within single quotes. And the exact same output. So it does not matter whether you use single or double quotes. Now let's check out the type of this variable. Type x and str, which is a short form for string. So now that we had a look at integers, floats, and strings, let's move on to some of the data types specific to Python. The first one we look at is list. So a list is basically a collection of values. So far we assigned a single value to a variable. With lists, we can assign multiple values. And this is how it's done. So give the variable name equal to, open square brackets, and within this you type your values. So 14, 67, 9. Run this, no error. Now let's print x and see what this results in. As you see, when you print x, all the values you stored within it is visible. Now let's check out the type of x. And the type is list. Now with list, since there are multiple values stored within a variable, you might be wondering how you can extract a single value. So this is simple. Each value in a list has an index. So you always start with 0. This is the 0th position, first position, second position. So if you want to extract 14, then you type print x0, and that will display 14. If you want to print the last value, print x2, because we start from 0. So this is 1 and this is 2. So that should print 9. Great. Now we'll change the values which are stored within the list. So if I say x2, which right now is 9, but I want to change this to 67. So that is a simple statement how you can do so, and run. Now let's see what x holds. So when you just type x, you're printing every value within x, and when you give a particular number within the square brackets with x, you're printing the value at that particular location. So print of x, run. And as you can see here guys, previously x held 14, 67, 9. Now it holds 14, 67 and 67 again because we changed x of 2 to 67. So now that we are done with lists, we'll move on to another data type in Python. This is called tuple. So with tuple 2, it's about the same thing. You can store multiple values in a single variable. The syntax for doing so though is slightly different with tuples. So instead of square brackets, you now have round brackets. And within that, you type in your values. So I'll just put 4, 8, 6. And let's print x. So all the values within x is printed. Now let's check the type of x. And the type gives tuple. So you might be wondering what is the difference between list and tuple. Now the core difference between list and tuple is that tuples are immutable. So what I mean here is that in case of tuples 2, you access each value within it in the same way you do with lists. So if I want to access the value 8 in x right now, I'll just give x within square brackets 1. Print this. And it outputs 8. But now, if I want to change this value, so the way of doing that, as we saw with list, is x of 1 and the value I want to change it to. So let's say 5. And I run this. We get an error. So you cannot change the values in case of tuples. Once you have stored the value within the variable for a tuple, it remains that way right till the end. And in technical terms, this means that tuples are immutable, while lists, for which you can change the values, they are mutable. So now we have something slightly different. When we deal with files, we need a variable which points to a particular file. So in general, these are called file pointers. The advantage of having file pointers is that when you need to perform various operations on a file, instead of providing the file's entire path name or the file's name every time, we can just assign it to a particular variable and use the variable instead. So this is exactly the advantage variables have with all other values too, but the syntax for doing so with files is slightly different. So I give x equal to open and within brackets, open quotes, enter your file name. So I want to open, say, a file called variable_com, and this is IPYNB, so it's my Python notebook. And the mode I'd like to open it in, so R. Let me run this. No error, so it's fine. This kind of an assignment is completely legit. Now we'll check the type of x. So as you see here, the type for x is _io.text_io wrapper. So in Python, this is the particular type assigned to this variable. But in general terms, you can refer to them as file pointers. Now suppose you want to assign values to multiple variables. What you can do here is instead of having statements like x equal to 5, enter, y equal to 10, enter, z equal to 7, instead of having 3 such statements, delete, open bracket, x, y, z, within bracket, equal to 5, 10, 7. And this works exactly the same. So now if you print x, y, and z, you'll see that they have been assigned their respective values. Of course, the number of variables and the number of values on either side should match. So if you put x equal to y, so if you give x comma y equal to 5, 10, 7, this would result in an error because you have only 2 variables on your left hand side while you have 3 values on your right hand side. Now suppose you want to assign the same value to multiple variables. In that case, you can do, now suppose you want to assign a value to multiple variables. Say x equal to 1, y equal to 1, z equal to 1. A short form to this, as you saw previously, would be x comma y comma z equal to 1 comma 1 comma 1. But then again, you'll have to type the same value 3 times. Instead, what we can do is x equal to y equal to z equal to 1. And this would work perfectly fine. So if I print the value of x, y, and z now, they all have the value 1 stored within them. So we have covered the various data types in Python and how you can assign values to a variable in multiple ways. We'll next move on to the various rules for naming the variables. Now there are certain rules that you must follow while naming the variables. We'll go through each of these rules and simultaneously I'll also demonstrate to you in our notebook the validity of each variable. So our first rule is variable name must begin with an alphabet or an underscore. So let's move on to our notebook. So ABC equal to 100. This should be valid because it starts with an alphabet. At the same time, underscore ABC would also be valid. So if the variable starts with an alphabet or an underscore, it's a valid name for the variable. But if we say 3A equal to 10, this would result in an error. Of course, because the variable name starts with a number and this is invalid. Same way, we cannot start the variable name with a special character other than underscore. So if I say @ABC, this would also result in an error. As you see, the error is invalid syntax because that is the invalid syntax for a variable name. Let's now look at the second rule for naming variables. The first character can be followed by alphabets, numbers, or underscore. So our first character must be an alphabet or an underscore. And after this first character, we can have alphabets, we can have numbers, or we can have underscore. So back to our notebook. By the second rule, 100 should be valid as it is. And if we put underscore, which is a valid starting character, 984, so our first character is followed by a letter, 3 digits, and then another underscore. This should also be valid because at the end of the day, it only consists of numbers, letters, and an underscore. However, if our variable name is A9967, few digits, and then a $sign, would this work? Well, no, this would result in an error, invalid syntax, because as already mentioned, for variable names, the only special character you can use is underscore. What about XYZ -2? Again, this would be invalid because it includes a special character that is not underscore, can't assign to operator. Let's have a look at our third rule. Variable names are case sensitive. So what case sensitive means is that small letters and capital letters are treated differently. So let's move back to a notebook and say I assign a value 100 to a variable A100, small a, and I assign another value 200 to a different variable, capital A100. So as you see here guys, between these two variables, the only difference is that the first variable has a small a and the second variable has a capital A. Let me just execute this. If I print the value of A100 and capital A100, you'll see that both these variables are recognized as completely different variables. They have their individual values. So now that we established that variables are case sensitive, we can also say that Python itself is a case sensitive language. Now a final rule is that reserved words cannot be used as variable names. Now if you have gone through any other languages like C, C++, Java, you know this is a common rule among all of them. You cannot use words which have special meaning to the language as variable names. So some of these words are break, class, try. You have other words such as continue, while, which is a loop, or if, which is a statement, a conditional statement. So let's go back to our notebook and see how assigning values to these reserved words can result in errors. So if I give break equal to 10, that would be an error. Similarly, class equal to 5 would result in an error. try equal to 100 would also result in an error because these words break class try have special meaning to Python. And with that, we cover the various rules for naming variables. The next thing we'll check out is the arithmetic operations that you can perform on these variables once you have stored integer values in them. Also perform various arithmetic operations with variables that store integer or float values. So let's have a look at some of these operations that we can perform. We'll start with initializing two variables. So x equal to 20 and y equal to 10. And now we'll perform our operations with these two variables. So first, let's check out how addition works. Result equal to x plus y. So result is a new variable and it should store the value of x plus y. Let's print this out. And as you see, x plus y equal to 30. So now result stores 30. Similarly, we can perform subtraction. We'll print this out too. So 20 minus 10 is 10. We can also perform multiplication. We use asterisks for the multiplication sign. So 20 into 10, that's 200. Next, we'll check out division. So as you can see here, in case of division, the result is not an integer but rather a float. If you want your result in integer, what you can do is instead of putting just one slash, you can apply two slashes. So x slash slash y. And print the result. And there you go. Now you have the result in integer. So in this particular case, since 10 completely divides 20, the requirement of the double slash is not very visible. But if we do division for numbers that do not divide each other completely, for example, if we have result equal to 2 by 3 and we print the result, we get 0.66 and so on. But if we give double slash here and run this, we get the result as 0. So in a lot of cases, the result from double slash makes way more sense than from single slash. So this is an extra benefit you have with Python, which is not present in many other languages. We also have the modulus operator here, which gives the remainder rather than the quotient. So if I say x mod y, it'll give me the remainder of the division from x by y. And the remainder is 0 because 10 completely divides 20. On the other hand, if you do want to see the remainder, you can give numbers such as 3 by 3 mod 2 and then print the result. And as you see, the remainder of this operation would be 1. Now, so far we saw arithmetic operations with integers. All these operations can also be performed with floating point numbers. So if your x value is 3.14 and your y value is 5.7, let's just perform one operation using the new values of x and y to see what it looks like. So let's say result equal to x by y, print result, and there's your quotient. So arithmetic operations work both with integers and floating point numbers. Next, let's check out some of the operations you can perform on string variables. As I mentioned earlier, strings are basically a collection of characters. So let's look at a few string operations. First, we'll initialize a string variable. So var equal to Simplilearn. And we'll perform all our operations on this var variable. Now, the first thing we'll do with this string variable is we'll see how we can extract each character in string. So just like in case of list and tuples, every character in your string has an index and it always starts with 0. So the first character is at location 0, second at 1, third at 2 and so on. So if you want to extract the first character of your string, which is S in our case, we just do var of 0. And as you see, S is printed. Similarly, if we want to extract the fifth character of our string, we'll put var of 4. So if you want to extract nth character, your index for it would be n minus 1 because we start our index from 0. And that prints L. So as you can see here, S is 0 and then we have 1, 2, 3, 4 and that is L. So now that we learned how to extract a single character, let's see how we can extract multiple characters from the string. Suppose I want to extract the first 3 characters. In that case, I would say var of the first 3, so my starting character would be at 0. So if I want to extract the first 3 characters of my string, what I'm basically saying is that I want to extract the character at the 0th, 1st and 2nd position. Then I'd say print of var of starting from the 0th location up to the 3rd location. We say 3 and not 2 because the last index is always excluded. So if I put 2 here instead of 3, then only the 0th and the 1st character would be printed. So I want my first 3 characters to be printed. So var of 0 to 3 and I'll run this. And as you see, the first 3 characters have been printed, capital S followed by IM. Now if you want to start from your first character, you can also just ignore the 0. So you can say var of :3. That is, we are not typing the 0 in this case. It's automatically understood that you start extracting from the first character when you miss out the 0. So you run this and as you see, it's the same result. Now if you want to print the character starting from the 5th location until the end of the string, you can go with print of var of 5th character, so 5 and up to the end. In this case, you do not need to mention the last index. You can just leave it blank and it's automatically understood that you're printing till the very last character of your string. And as you see, from your 5th index to the very last character has been printed. Now suppose you give var of 0 to 20 and it's pretty obvious that you do not have 20 characters in this particular string. So you do not have 20 indexes. So what do you think would happen if I do 0 to 20? Well, the entire string is printed. So although we have only 11 characters in our string and we have given the ending index as 20, this does not result in an error, just our entire string gets printed. Now if you want to find out the length of your string without actually having to count it manually, you can use the function len of var. Len is an inbuilt function in Python. Now run the command and as you can see, we have 11 characters in our string. So those are the basic operations you can do with a string variable. I hope this is very clear to you, as in the end we have a small quiz which uses some of these concepts. So now that we have gone through the various concepts of variables, let's have a small exercise where we'll be using string variables. So we'll have 2 strings. One string says it's Sunday and the other stores have a great day. Using only these 2 strings, we need to build a 3rd string which says it's a great Sunday. So let's have a look at how to do this. We move back to our notebook. The first thing to do is we store our 2 source strings in separate variables. So let's have variable var1 which stores our first string. It's Sunday. And we have the next variable var2 which stores our second string, have a great day. Now using these 2 strings, we create our 3rd string which is var3. So first let's run these 2 statements. So now var3 needs to store it's a great Sunday. The word it's comes from var1. So var1 and it starts at the first location. So 0, which we can ignore because it's automatically assumed to be 0. And we require all the characters in var1 from the 0th position until the position just before our capital S of Sunday. So that would be 0, 1, 2, 3, 4. So our 4th position is the blank space. Since we want to include the blank space too, we give our ending index as 5. Now the next part of our string, it's a great Sunday, needs to include a great from var2. So var2. So the next part of our string is a great, and a great comes from var2. Now this subscript starts from the 5th position in var2. So our starting position would be 5. And at the 12th position in var2, we have the space that comes after great. Now we need to include the space too, so we'll go with our ending index as 13. And finally, our last word of It's a Great Sunday, which is Sunday, will come from var1. So var1, and the word Sunday starts from the 5th location in var1. So our starting index here would be 5, and we'll take the entire string from the 5th location. So we leave the ending index empty, and that's it. So let's run this. Now let's just check if what we did so far is correct. So we'll print var3. And yeah, that's perfect. As you can see, we have It's a Great Sunday in var3, which is exactly what we wanted. So now a short quiz for you. So if you're familiar with other programming languages, but for those who are completely new to programming languages, definitely try this out. So we have a variable a, which holds a value 100, and we'll have another variable b, which holds a value 200. Now the task is we want b to hold the value 100 and a to hold the value 200. So basically you're swapping the values between these two variables. So give this a thought and post your answers in the comment section below. We'll give out the answers soon enough. And with that, we come to an end of Python variables. So what are lists? A list is a collection of data, and this data could be of any data type. In fact, a list could hold data of different data types. As we can see in our example down here, we have a list named X, and X holds 1, 89, the single letter A, the string hey, another number 0, and the capital letter B. Now another important factor with lists are its indices. Every element in the list has a position, and this position is called an index. The first position in a list is always 0. So 1 is at index 0, 89 at index 1, A at index 2, and so on. So this means that the position of your last element would be the length of your list minus 1. So now that you know what a list is, let's move on to how you can create a list. So this is my Jupyter notebook, and we'll start by creating the most basic list, which is an integer list. So my list name would be num, and then open square brackets, and within this, just put in your numbers separated by commas. So that is my first list. Run this, and there seems to be no error. Let's now print this list out just to see what it looks like. And as you can see, the elements that we inserted in this list are printed, which are 1, 2, 3, and 4. Next, let's create a list with just single characters. So my list name is letter, and the syntax is exactly the same. You open square brackets, and now that we have letters inside, which are characters, you type these within quotes. Let's print this too. And once again, after the run, you can see the letters that we inserted into our list letter. Next, let's create a list of strings. So I'll name my list stg, open square braces, and again strings should always be written within double or single quotes. And that's my list of strings. I'll print this too. Great, so now we have created a list of only integers, only letters, and only strings. Now, as I mentioned before, lists can contain a combination of different data types. So let's try that out. I'll name my list mix because it's going to be a mix of numbers, strings, two numbers, and then I'll follow this up with a few strings. And let's run it. So that works perfectly fine. Now lists have another format. If you have worked with any other programming language previously, you would have come across the term matrix. So usually in other programming languages, matrix are associated with arrays. So they are basically 2D arrays. In case of Python's, matrix can also be of lists. So you can have a list containing 2 or more lists. So let's do that. I'll name my list mat, as in short for matrix, open square braces, and since the elements of this list are also lists, put these two in square braces. So our first list would be 1, 2, and then comma, because our second list is basically the second element of our list mat. And our second list would be AB. And that's how you create a list containing lists. So our parent list is mat, and this contains 2 lists. The first list is 1, 2, and the second list is A, B. So let's print this out. And there you go. So we also created a list containing lists. So these are the different type of lists you can create. Next, we'll move on to how you can access the elements within this list. So there's no point of creating a list if you cannot access each individual element within the list. Now here, to understand how to access the elements of the list, we'll be using the list mix that we created previously. So before we start, I'll just print out mix so you can have an idea of what is inside. So we have 5 elements within mix. The first 2 are numbers or integers 1, 6. And that's followed up by 3 strings, Simplilearn, get, certified. We previously saw that every element in the list has an index position. So the simplest way of accessing an individual element in the list is by following the list name with square braces, and within the square braces, mention the index number of the particular element. So if I want to access the element get, my index would be 0, 1, 2, 3. So mix of 3. And I'll run this. We got our element get. Now in a similar way, you can also use negative indices to access the elements. So when you put a negative sign, the indices are basically counted from the back of the list. Now if I want to access the same word get, but all I know about this word's position is that it's the second last word in the list. I also do not know the length of the list. In this case, I can just say mix of -2. So 2 as in it's the second last element, and the minus signifies that you count from the end of the list and not from the beginning. So I'll run this and extracted get. Now as you probably would have noticed, in case of indices when counted from the front of the list, it starts with 0. On the other hand, when you count the indices from the end of the list, it starts with -1 and not 0. So now we saw how you can access a single element from the front of the list and from the back of the list. Now what if you want to access a range of elements? Say I want to extract the first 3 elements of the list mix. In that case, I could just type mix, again square braces, and within here I'll put colons followed by 3. So ideally there would be a number on either side of the colon, but in this case we are taking from the beginning of the list. So if the digit before the colon is supposed to be 0, you can just leave it blank and automatically it's interpreted as 0. Also, we know that our third element would be at the index position 2. But here we have written index position 3. This is because our last index position is always excluded. So if you give 2 instead of 3, then the only elements that would be extracted would be the ones at 0th and 1st position. Since we want the element at the second position too, we give the ending index as 3. So let's print this. And we received our first 3 elements of the list mix, which are 1, 6 and the word Simplilearn. Now what if we want to extract all the elements from a certain position of the list, say our third index position of the list up till the end of the list? In that case, again, we have mix square braces, and we have the same colons as we used previously. But now, since we want our starting index to be 3, we enter 3 and the element at the third index would be included. But now we want to extract all elements till the end of the list. So you can just leave the last position blank. When you do this, it's automatically interpreted that you're taking all the elements up till the end of the list. Let's run this. and we received get and certified. Now I want to extract the words Simplilearn and get from our list mix. In this case, what would be the parameters within our square braces? So Simplilearn is at the index location 2 and get is at the index location 3. So our starting index would be 2, but as we already mentioned previously, if I put 3 as my ending index, I would not receive the element at the index position 3. Therefore, I'll put my ending index as 4 and run this. And there you go, we received our two words Simplilearn and get. Now here's something slightly more fun. So what if I want to extract every second element of my list? In that case, I put 2 double colons followed by 2 because I want every second element of my list and run this. So as you see here, 1 has been printed, which is followed by 6 in our list mix, but 6 is skipped, and then we have Simplilearn. Again, the word get is skipped and we have certified. Now there's one more thing you can do with list indices. You can print them in the reverse order. So to do that, just 2 colons and -1. Let's print that. And as you can see, your list mix is printed in the reverse order. So now if we go back to line 16, these 2 double colons are basically positions for your indices. So suppose you want the second element from the first index and not the 0th index, you can write 1 here. And if you want every second element from the first index up to say the 5th index, you can put 5 here, but in our case, we do not have a 5th index. So I'll just leave it at this. You can obviously try that out. In fact, we'll be using a variation of this in our exercise later on. So now that we saw how you can access the various elements of the list, let's look at the various operations you can perform on the list. Suppose you want to create a list of 100 zeros. If we go by the traditional methods, we'd literally have to type in 100 zeros separated by commas within the square braces. And this gets very tedious. So a short way of doing this is type in that one element that you want repeated multiple times within your list, and outside the square braces, follow it up with asterisk, digit, and the number of times you want this element to be repeated. So 0 into 100, and let me print this. And as you see, 100 zeros exist within our list Z. Now we can also create a new list concatenating 2 or more lists. So let's create a list concatenating the 2 lists that we previously created, letter and stg. So I'll just print these lists out first. That's our list letter. And that's our list stg. Now we'll create a new list called conc, a short form for concat. And how do you concatenate 2 lists? Well, you just add an addition sign between them. So letter plus stg. And that's all it takes to join 2 lists. Let's print out conc. And there you go. So the first 4 elements in our list conc is from the list letter, and the last 4 elements is from the list stg. Now there's another operation with list called unpacking. So here you basically give a string as an argument to this function list, and that unpacks each element of the string as a separate element in the list. So I'll show you this with an example. If I name my list var and list of within the brackets, I enter the string. I say, hey there. And now I'll print var. So as you can see, every letter of this string, hey there, has become a single element in the list var. Now let's check out another operation on list using the list num that we created previously. So once again, I'll just print num out so we can recall what was within it. We had the 4 numbers 1, 2, 3, 4. Now suppose I want the first element of my list num, which is 1, to be in a variable 1, and I want the rest of the elements to be stored in another list called, say, others. How do I do this? I can just put 1, which is my first variable, a comma, and then star other equal to num. So what happens here is that this star signifies that every element that has not been put into the previous variable or variables is put into this list other. So let's print out the variable 1 and the list other separately and see what they contain. And as expected, 1 contains the value 1, which is the first element of our list num, and the following elements of our list, which are 2, 3, and 4, are stored in the list other. Let's now look at a few methods specific to list. So for the following few examples, we'll be using the list that we created previously called num. I'll print the list out first. So num has the elements 1, 2, 3, and 4. Now the first method that we'll be using is the append method. And the syntax for that is the list name, which is num.append, followed by brackets. And within these brackets, you basically insert the element that you want to add to the end of your list. So suppose I want my list to be 1, 2, 3, 4, 6. All I do is enter 6 here, and that should ideally add 6 to the end of your list num. So now let's print out num. And there you go. So previously our list contained the numbers 1, 2, 3, 4, and after we executed the num.append method, 6 was added to the end. Now what if we do not want to add a single element to the end of the list, but an entire other list? So in this case, we can use the method extend. The syntax for this is num.extend, and within the brackets, you'll enter the name of the list you want to add to your previous list. So here I want to add the list stg that we created previously to the end of my list num. Now before I execute this command, let me just print out stg so we know what's in there. So within stg I have get certified get ahead. I'll just delete this cell and now I'll run the command. So let's print out num. And as you see, num previously had 1, 2, 3, 4, 6 from here. And then we added get certified get ahead to the end of this list num. Now these kind of additions only take place at the end of the list. What if we want to insert an element somewhere in between the list? For this, we use the method insert. And the syntax is your list name num.insert, and within brackets, you first enter the position or the index at which you want to enter the new element. So I want to insert the string Simplilearn just before get. So this is my 5th position. So my first parameter here would be 5, followed by the element I want to enter, which is a string Simplilearn. So I'll type it within quotes. And let me run that. Let's now see what num looks like. And as you see here, we have 1, 2, 3, 4, 6. And then we have the new element that we just inserted, Simplilearn, followed by the elements which were previously in our stg list alone. Now there's another method you might come across regularly, which is the remove method. So this method, as the name suggests, removes an element. It basically removes the first occurrence of that particular element. So the syntax for this is num.remove. And within the brackets, you enter the element that you want to remove. So I'll remove the element Simplilearn and run. Let's now see what num holds. So as you can see, Simplilearn has been removed. Now if there were 2 occurrences of Simplilearn, one here and maybe one after ahead, only this word would be removed and not the one later on, because it removes only the first occurrence of that particular word or that particular element. Okay, so now let's create a new list, say var1, and we'll just insert a few letters in here. Now imagine you receive a list like this where there are few elements but in a jumbled order. You want to sort out this list. One simple method, sort, is all you need to do. var.sortOf, run it. And now let's print out what var1 holds. So all your elements in var1 are now sorted. Python also provides a few built-in functions that can be used with lists. So we'll have a look at the most basic ones. So before we begin, let's create a list, x, and I'll fill my list with just integers. So that's my list, and we'll use this list throughout all our built-in functions. Now the most basic built-in function and the most commonly used is len. What len does is it tells you the length of your list. So len of x, and the length is 6. Our next built-in function that we'll try out is min. Min gives you basically the minimum of all the elements that's present in your list. So min of x, and the minimum element in our list is 4. Similarly, we also have max, which gives you the maximum of the elements present in the list, max of x, which is 90. Now we also have a function sum, which basically gives you the sum of all the elements present in your list. So sum of x, and that's 189. Now in Python, we do not have a function which gives you the average, but it's very simple to calculate this. We do so using the sum function. So you find the sum and then you divide that by the length of the list. So sum of x by len of x would give you the average of x. So with that, we covered the basic built-in functions for Python lists. We also covered the methods in lists, a few operations in lists. We saw how we can access the various elements in list. So for our exercise, we need to create a list of numbers from 1 to 10. We'll call this list 1. And then we'll split list 1 into two lists, odd, which contains all the odd elements of the list 1, and even, which contains all the even elements of list 1. So now let's move on to a Jupyter notebook and see how this is done. So let's first create our list 1, which will contain all the elements from 1 to 10. Now you can use the traditional methods and enter all your numbers from 1 to 10 within these square braces separated by commas. Or we look at a simpler way of doing this. Just say list, and to this you pass the function range, and within range you specify the range of the elements you want within list 1. So I want all the elements from 1 up to 10. So my ending index would be 11 and they are separated by commas. Let's run this and let's print list 1. And there you go. So all your digits from 1 to 10 is stored within list 1. Now the next thing we need to do is, as I mentioned earlier, we need to split list 1 into odd and even. And odd list will contain all the odd elements and even will contain all the even elements. So let's start with odd. So my list name is odd and the elements will be taken from list 1. And now the tricky part, how do we specify the indices in this case? So if you remember previously, we had gone through an example where we want to access every second element, in which case our index was mentioned like this, where the 2 indicated that every second element would be taken from the list. So in this case too, since odd numbers occur after every second element, our interval is still 2, and we'll start from the 0th position of the list, which is 1, and go up till the end. So this is our command. Let's see what odd holds. And as you can see, odd has all the odd numbers from list 1. Now we need to store all the even numbers from list 1 into this list even. Again, our interval would be 2, but this time if we just skip every second element from the beginning, even would have all the odd numbers. So what we do is we'll start skipping the second element from our second element. So from index 1 onwards, we'll start skipping every second element. Let's print out even. And there you go. So our list even has the even numbers 2, 4, 6, 8 and 10. So with that, we successfully completed our exercise and we also come to an end to lists in Python. If you have any doubts, please post them in the comment section below and we'll definitely get back to you. Please hit the like button if you like the video. Also subscribe to our channel as we have a lot more coming up. This is Anjali signing off. See you all next time.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.